Okay, so this is pretty cool. You have so far created a word count application, and now we just finished the to-do list application, and I showed how to run the to-do list application using Scala CLI. And what I want to do now is take a few moments to kind of recap where we started from and where we are right now. So way back in the beginning of the book, I started off talking about Java and OOP programming and talked about how little we use types. And then I also started stating these rules for programming that we would use inside this book. So these rules are we would only use immutable variables, immutable data structures, pure functions. That would lead to expression-oriented programming. And we would use error handling data types like option, try, and either. And in this particular case, we would use try anytime we access the outside world. And in this example, we created our own flat file database, and I asked you to use your imagination that we were either accessing a remote database or a REST service, both of which can be inaccessible at any time. And I mentioned my reasoning for doing both of these is that I looked at using Scala database libraries, but they were a little bit too complicated in that they already implement functional programming techniques, so that didn't help for where we are right now. And then I also looked at writing REST services, but that also got more complicated. And it's things that we don't need to know right now. It's like we're just working through this, we're getting comfortable with using try. And what I was trying to do, no pun intended, in this code was show how try sprinkles throughout your code. So we started off by using try in all of these database functions because insert can fail and select all can fail and delete can fail. So we use try here. And then you saw inside the input processor class how that try ends up coming into all of these other functions all around here, and even into this handle user input function. So that was the thing I was trying to show you. And to me, that's much more important than trying to show you a real database and trying to show you real REST services right now. And as I mentioned, when we started off this book, we weren't talking about data types very much. So if your background was Java and object-oriented programming or any other object-oriented programming languages, you may not have been seeing data types very much. But now that we've written these two small applications, you've seen a lot of data types. And a lot of what you saw was me sketching these function types before we did anything else. Sometimes I got away from that, but in general, I would try to sketch a function type so that we could imagine how the body of the code was going to work. And then we were just focusing on what comes in and what comes out. And that's a big part of functional programming. You'll do that a lot. And on the bottom of this page, I think that this is a good time to ask if you feel that there are benefits to all these techniques, and if so, what are they? So for me, I think the benefits I demonstrated are, as I've mentioned several times, you can trust pure functions. Their type signatures can't lie. And we saw that starting with the makeInt function, and we saw that with all these other functions over here. And a key to that is when you see these types like option, try, and either, you can instantly think, oh wow, something can go wrong inside this function. So if you've never seen that function before, what I'm saying is if I have never seen, let's say I've never seen this handle delete function before in my life, I can read this and see that a string is coming in and then a try is right over here. So I could say, oh, okay, this function can fail. That's what the writer of this function is trying to tell me, is something can go wrong inside of this function. And that's what I mean by this point right here. Another thing I've noted is that when you look at a function signature and you see that it either takes no input parameters or it has the unit return type, you can instantly tell, oh, this function is probably performing some type of side effect. And then another thing I demonstrated is that even when I don't know the name of a function, I can look at its signature and get a good idea of what that function can possibly do. And I just covered that example right here when I was talking about this. Then to me, I can add in these other statements. And the first one is that reading expression-oriented code can be as simple as programming gets. You're binding the result of a pure function to an algebraic variable, and then you're doing another one, and then you're doing another one. And that code is easy to write, read, and test. And over here, probably the closest example I have of that, most of this code is very short also. As you notice in Scala, a lot of your code and a lot of your functions can be one-liners like these guys right here. But this is kind of expression-oriented code here because I'm saying, well, I'm going to do this. The reason I was hesitating is because that can throw an exception. But As you saw in previous examples and a word count example, and if I had written this code differently, we would have val variable name equals some pure code over here, then val variable name equals some pure code over here, and then in this case, I'm returning this value here. So even though I took a few shortcuts in this function, I believe that code is about as easy to read as programming gets. Then the next thing is writing code like this to me is like writing algebra or creating a blueprint. And maybe a good example of that is over here where I start binding these things together. We talk about binding things in functional programming, and that's kind of what I do here is I put this code inside of this for expression, and this allows me to run things in sequence. So I run this one, and then I run this one, and then I run this one, and then I run this block of code right here in this example. So this is where we start binding functions together. And then this delete function here inside the database class is another case where I use the same approach inside of a for expression. So again, we're doing these things so everything runs in order. So I say I want to do a select all, then I take that result and I operate on it. I should mention that there is some side effects still in our code. So this is a side effect right here of writing to a file. But generally, we're binding things together and saying I want to do this first, then I want to do this, then I have this side effect, then I want to do this call right here. So let's do these in order, 1, 2, 3, 4. Then I want to calculate this right here. And finally, I want to yield that result right here. And this gives you a little flavor of how we bind pure functions together and their values. So here I probably should have said that writing pure functions is like writing algebra. And then when you start combining those expressions together, that's where it starts to feel more like combining algebraic equations. And some people call this combining process composing or composability of your equations or your functions. A few other things I know from my own experience that I haven't shown here is that immutable variables and immutable data structures are safe to use in parallel and concurrent programming. And then another thing that I know here is that pure functions are easier to test than methods that perform side effects. And in regard to that, I talk about this. So an impure function can do any of the following things, and I actually missed the part about throwing exceptions. So if you think that number one is that they can throw exceptions, the other thing they can do is read input from the outside world without warning callers. Another thing they can do is read input from the outside world without warning you as somebody that's looking at the function. You could look at the function and never know that they're reading input. You could look at the function and never know that they're writing output. They can mutate the parameters they're given. They can mutate variables inside their class or mutate global parameters. And they can access any other variable they want through side doors. So all of these things here, as well as throwing exceptions, make impure functions harder to test. At the very least, just because you know that setting up their state is going to take more work. When you have a pure function, everything the pure function needs is going to be going in that front door. And with impure functions, you may have to set up some things over here in a global environment just so you can test an impure function down here. And finally, you may have been wondering why I just went through everything I did. Why did I create all this code? Why did I create this database code and show all these try values here and show for expressions over here? And what else did I show? Gosh, I showed blocks of code like this. I showed how we use recursion to handle looping and everything else I showed, including immutable variables, immutable data structures, and expression-oriented programming. And the thing is, if you understand everything I've done so far, you are actually so close to functional programming. You may have no idea how close you are if you've never done this before, but you're so close. All we have to do is just take a few more steps and you're going to be knocking at the door of functional programming. And again, if I go back to the goal of this course, it's getting you ready to use the Zio functional programming library. And I think you'll see after the next few lessons just how close we are to doing that.